Alright, so another way that we can describe units of measurement for concentrations of solutions is by parts per million or parts per billion. And we use these measurements when we have very, very small quantities of a substance inside that solution. So oftentimes you'll see the EPA, for example, will use the terms parts per million or parts per billion when they refer to toxic substances in the environment or other harmful materials that at very, very low concentrations can cause a problem. So this provides an easy way to track these types of toxins. So essentially, 1 part per million denotes that there's 1 part of something in a million parts of something else. And so oftentimes this will be a toxic substance in, say, water, for example. Water is a very common substance that parts per million measurements are going to be made in. So, for example, if you're testing your well water, you might be looking for the concentration of lead in the well water. And so you might denote that as 1 part lead per a million parts water. And so that would give you your parts per million. 1 part per billion then would denote 1 part of something in a billion parts of the other thing, or 10 to the 9th. So 1 part per million denotes 1 part per million parts, or 1 part in 10 to the 6th. So for contaminants in water, 1 part per million is equivalent to saying 1 milligram of contaminant in 1 liter of water. So essentially 1 part per million is 1 milligram per liter of water. And why is this true? Well, if we look at the density of water, we can reason this out. We would note that if we are using a milligram measurement for parts per million, we would have to say that 1 milligram is going to be in 1 million milligrams of something else, right? So if we had 1 milligram of lead in a million milligrams of water, that would constitute 1 part of lead per 1 million parts of water. And so we have to actually get this into then the same type of measurement. So thinking about milligrams and liters, this one is measuring weight, this one is measuring volume, and we know that volume and weight occur within the same equation when we're talking about the density of a substance. So if we reason that 1 part per million is going to be derived from the fact that the density of water is taken to be 1 kilogram per 1 liter, or 1 mg per mil, essentially, then we would have 1 million milligrams in 1 liter of water. So 1 million milligrams is going to be equivalent to that 1 liter of water, so we can substitute in the 1 liter of water rather than saying 1 milligram of contaminant in 1 million milligrams of water, because that's kind of hard to say. It's easier to say 1 liter. So since these are equivalent terms, we can say that 1 part per million in a water system is going to be equivalent to 1 milligram of the toxic substance that you're measuring in 1 liter of water. And so you just either have to remember that, or you have to remember this density conversion so that you can get there by the weight. 1 part per billion, on the other hand, is going to denote that you've got 1 part per 1 billion parts of the other substance. So 1 part toxin, again, to 1 billion parts of water. So this unit is 1,000 times smaller than our parts per million. So it would essentially be 1 milligram in 1 billion milligrams of water, or essentially 1 milligram in 1,000 liters. So our 1 part per billion is 1 milligram in 1,000 liters, or we can reduce that and say 0.001 milligrams in 1 liter. So parts per billion is smaller than parts per million. So here's a question to try to practice. So if you have something that's expressed as parts per million, what would be the concentration of the solution that contains 20 milligrams of glucose dissolved in 100 milliliters of water? And our solution density is going to be 1 kilogram per liter, so that we can substitute in here. Well, we know that 1 part per million solution is 1 milligram in 1 liter. So that's really what we need to get our concentration in. We need it in milligrams per liters, right? So we would have to convert our volume into liters. So how would we go about doing that? So essentially, the first thing we need to do is convert our milliliters into liters. So now we have our volume in liters at 0.100 liters. And now we need to set up our parts per million solution as milligrams per liter and get that concentration worked out. So if we finish working out this equation, what we see is if we divide 20 milligrams by our volume of 0.100 liters, what we come up with is 200 milligrams per liter. And we know our milligrams per liter concentration is equivalent to parts per million. So we can also say that this is 200 parts per million solution. So hopefully this makes sense, and parts per million, parts per billion shouldn't give you too much problem. You just have to remember that it's milligrams per liter for our parts per million and milligrams per 1,000 liters for parts per billion, or micrograms per liter, essentially.